Hi guys, today I am going to describe how an FM radio works. FM radio uses frequency modulation, in which frequency of the input signal is changed, keeping the amplitude constant. FM radio works in frequency range from 87.5 MHz to 108 MHz, which is much higher than the range of frequencies used in AM radios. Although FM radio signals you have much less range, which is about lower than 100 miles, but they get much better quality of music over AM radio signals. That's why we use FM radio over AM ones. Now I am going to describe the various components present in an FM radio. The first component is antenna. It is responsible for intercepting the waves coming to the station. These waves flow through the metal antenna and causes tiny AC currents to flow within it. By Faraday's law, whenever there is a flow of electrons in a conductor, a varying magnetic field is produced around that conductor. This is the principle at which radio signals are intercepted. Radio waves are electromagnetic waves which are generated by an element called transmitting antenna, while they are absorbed by another element which is called receiving antenna. The next component is known as RF filter, which is an optional component also. It enables only selected frequencies to pass through it to go to next components, while it rejects the other frequencies which are not required. The ideal filter will exhibit no loss within the pass band, that is, the frequencies below cutoff frequencies. Above these frequencies, it rejects all other signals. Moving on to next component. The next component is known as RF amplifier. RF amplifier is a tuned amplifier which provides initial selectivity. The frequency at which maximum gain occurs in RF amplifier is made variable by changing the inductance or capacitance of the tuned circuit. Heading over to next component, it is known as mixer. Mixer changes the incoming frequency by mixing the incoming signal with local oscillation signals. Local oscillator is a variable frequency oscillator which is used to tune the radio to different stations. This frequency conversion is called heterodyne, which helps in selecting the stations that we require. Next we have IF filter. The full form of IF filter is intermediate frequency filter. Actually, the incoming signal has been mixed with local oscillator signals, and hence it is now known as intermediate frequencies. So IF filter filters these intermediate frequencies. Its choice depends on particularly radio design, cost, performance and the frequency of operation. These days LC filters are not used because their cost of winding coils is much high. So we use ceramic filters nowadays. Next we follow to IF amplifier. Actually the signal has been mixed with various other signals up till now, so it has been weakened too much. IF amplifier is used to amplify these weakened signals. After that the signal goes to demodulator. Demodulator refers to the process of extracting original information back from modulated carrier waves. These extracted signals are then amplified by audio amplifier and then sent to the loudspeaker. Now I will explain how stations are changed in a FM radio. A simplified circuit of FM radio is shown here. The signals arrive at the circuit through the antenna. The capacitor C1 is actually a variable capacitor here, and hence it actually helps in changing the stations. The signals are then passed to C2. Through C2 they move on to further. The 10K resistor is actually a variable resistor here, which controls the volume to input of amplifier. A coil shown by L1 is also present here, which actually behaves as inductor. Now to change the signals, we change the value of capacitance of capacitor C1. Doing so changes the resonant frequency of the circuit, and hence when this resonance frequency becomes equal to the frequency of input required signal of the required channel, the antenna starts catching signals from that channel, and thus our channel is changed. Okay, thanks for hearing it. Bye.